Hey y'all, let's cover guided notes 3.7. I'm very surprised I didn't have this video already out there to you. Sorry about that, but luckily I haven't taught it in class yet. Verifying that two functions are inverse functions. Okay, I know that most of the time we just look at this and just think, oh my gosh, that's just a bunch of gobbledygook. I don't want to waste my time reading it. But this is really good. I mean, most of the time they're really good in letting you know what's happening. And at this point in your mathematical career, you should be able to look at this and be like, okay, I can make some sense out of this. And let me help you. All right. So for any one-to-one function, all right, so we've already discussed what a one-to-one function is. It has to be a function first. And then for every, what is it? Every one item in the domain, it only has one range. And for every item that we have in the range, there's only one piece in the domain for everything to be one-to-one. So I've been telling you for a while now that f of x is equal to y. Keep that in mind. We're going to use that quite a bit this time. A function, this is the inverse of x. They're giving you what it is, the inverse function of x of f if the inverse of y is x. Okay, that means nothing to you right now, and that's okay. We'll get there. Here's something else. The inverse of the original function. This is big because if you take the inverse of the original function, we're going to get x, okay, for all x in the domain of f. It also follows that if you go the other direction, if we take the inverse of x, the inverse of f, and take the function of that, then we would get x. That would just let us know that f, the inverse, is also the inverse of f, okay? Just sounds really confusing. And when I keep saying to myself, all right, notation's read f of -1 is actually read f inverse, not f of -1, all right? This is huge right here. When you think the inverse of f of x, the f inverse, it is not the same, even though it's got that -1 up there. This is not 1 over f of x, okay? Be very careful, all right? No, and not all functions have inverses. Sometimes we have to restrict the domains, and we'll find out more about that here in a minute. Okay, example 1, identifying an inverse function for a given input-output pair. So if for a particular one-to-one function, that means for every x, there's only one y, and for every y, there's only one x in this regard. What are the corresponding input and output values for the inverse function? Okay, well, if f of 2 is equal to 4, okay, and f of 5 is equal to 12, that's what they're telling us. So this is the function's f. Then that means that the inverse of this function f of 4 is 2, and the inverse of 12 is 5. So here's something really neat to start noticing, and we'll talk about this more, it will develop, but this is a great time to look at it. What is the domain for our f function? Our domain is 2 and 5. So the domain for f is the set 2 and 5. What's the range for our f function? The output. The range is 4 and 12. So the range for f is the set 4 and 12. Let's go the other direction. Let's look at the inverse. The inverse of f. What is the domain for the inverse of f? The domain for the inverse of f is the opposite of the domain for f. It's 4 and 12. I should have put this little cute curly cues. 4 and 12, because those are the inputs. And the range, which are the outputs for the inverse, is 2 and 5. So this should get you to thinking and start to understand that the domain for f is going to be the range for the inverse of f. And the range for f is going to be the domain for the inverse of f. right? Just start having a conversation here. All right. Here's the next one. Testing inverse relationships algebraically. So I want to do a little bit of talking about this before I actually go into this problem. And I'm going to do this problem after I do an easier problem first, just to help you understand the concepts. And the concepts here are this. If you're given two functions, and let's just ignore this guy right now and just come over here and do a little teaching before I do this example. If you're given two functions, let's say f of x and g of x. So let's say we have f of x and we have g of x. We've got two different functions here, right? I'm going to just create some real quick. F of x is the cube root of x minus 1, and g of x is x cubed plus 1. All right, so given two functions. To test the inverses, to see if they're inverses of each other, we have to do one or another of these things. We have to either take the f of g of x, or we have to take g of f of x. When we do each one of these, the answer we should get, no matter which one we do, we need to just choose one of them. The answer we should get when we do this is x. If they are truly inverses of each other, the function of g of x would equal x, or the function g of f of x would equal x. So let's check that out. If they don't equal x, then they're not inverses of each other. So let's see if my f of x and g of x here are inverses of each other. I'm just going to take f of g of x. Okay. So that's taking the function f, which is the cube root. Now where my x is, I'm going to plug in g of x. So x cubed plus 1. And then I've got a minus 1 over there. Now I just need to clean this up a little bit. Cube root of x cubed. Well, this is plus 1 minus 1, so those are gone. So we just have the cube root of x cubed. So I'm thinking, yeah, they're inverses of each other, because the function f of g of x is x, the composition. Okay. If you would have gone the other way, g of f of x, you would have gotten x as well. So because I got x, yes, they are inverses. Yes, they are inverses. Okay. All right. This is how you're going to have to prove it as well on the exam. There will be these on the exam. Now I'm going to go to this one because it was a little harder. I wanted to do the easier one first for you, just to make sure you understood the concept. But now we have two functions, f and g, and we want to see if g is the inverse of f. So all we have to do is we can go either way, f of g of x or g of f of x. I'm going to just go f of g of x. I kind of do the same thing all the time. Feel free to do g of f of x. It's your call. So I have to take the function f, 1 divided by where the x is, I have to put something, and then plus 2. So that's something I have to put where that x is the g function, 1 over x minus 2. Okay. All right. Well, that is equal to 1 divided by, well, that's 1 over x minus 2 plus 2. The 2's are gone. And now I have 1 over x. So I don't know how you think of this. I think of it as just a flip, but if it helps you to see this better, this is 1 divided by 1 over x. Keep, switch, flip is 1 times x over 1, and that is just x. So yes, g is equal to, I can do that. G is equal to the inverse of f. Okay, I'll just do that. And we know that because taking the f of g of x gives us x. And so therefore, yes, they are inverses. If we would have gotten anything else besides x, they would not have been inverses. And the answer would have been no. Let's go to example 3. We've got two functions with the cube root, and g is 1/3 x. and we want it to know if they are inverses. So I'm going to take f of g of x, and that is taking x is right here and it's cubed. G is 1/3 x. Okay. So that's just a one. I'm going to do x cubed divided by 3 cubed is 27. And that is what f of g of x is. And that is definitely not, that is not x. So therefore, no, g is not the inverse. Or yes, the g is not the inverse, but no, g is not the inverse. I'm just like negative into the negative out of this. They are not inverses of each other. Okay. All right. Please make sure any questions you have along the way that you write it down. Like that. Go to the next one. Okay. If you'll think back to the first thing I showed you was this one. And we proved that the domain of f is the range of the inverse, and the domain of the inverse is the range of f. They are just the opposites. And this is a little sketch to show you the domain of f and the range of f. They are just the opposites. It's just if it helps you see it a little bit better, there you go. Is it possible for a function to have more than one inverse? The answer here is no. It's not possible unless you restrict the domain. But given just the function, no. Domain and range of inverse functions. The range of this is the same thing. The range of the function f is the domain of the inverse function, and the domain of f is the same as the range of the inverse of f. All right. This next one here is example 4, and I'm sorry, cut off down here. I need to change some things up. Finding the inverses of toolkit functions. Okay, so that's the next thing we're going to do. Identify which of the toolkit functions besides the quadratic function, okay, are not one-to-one. So we need to know who's not one-to-one. And find a restricted domain on which each function is one-to-one, if any. Okay. All right, so I'm going to just do them all, just so we can see what's going on. All right. So let's look at, well, let's see what each of these look like. The constant function, constant is just, an example would be right here. Let's just say this is f of x is equal to 3. It's not one-to-one, right? Because I mean, it's a function. I can do a vertical line test. It's a function. But the horizontal line test is your one-to-one. And if you draw a horizontal line at 3, you're going to hit every point on that line. So it's not one-to-one. Is there anything we can do to constrict this line in order to make it one-to-one? And there's not, because that would be restricting us to 1 point. There's nothing else we can do. Kind of a cool thing here, though, the domain for this is from negative infinity to infinity. And the range is just 3, just 3, just the set 3. And then the inverse of that, well, there is no inverse. So there's no inverse for this one. This one is identity function, y equal x. And that is one-to-one, so we don't have to worry about it. Quadratic, they told us not to worry about it, but why wouldn't we? It's not one-to-one. It passes the vertical line test, but not the horizontal. And then we can restrict the quadratic by stopping it right here and only representing everything to the right. So we could restrict the domain to 0 to infinity. So I would restrict the domain from 0 to infinity, and then you would have a one-to-one. Then it is one-to-one. Okay. Cubic. Cubic is just like this. It is one-to-one.
So we don't need to worry about constricting it or restricting it. Reciprocal is also 1-to-1. So we don't need to restrict. Reciprocal squared is this guy. It is not 1-to-1. And we can do the same thing and restrict the domain. So we can restrict the domain to only be 0 to infinity. I'm not putting 0 in brackets because it never touches 0. Okay. So if you restrict the domain 0 to infinity, then it's 1-to-1. Next is cube root. Cube root is just this guy. There we go, sort of like that. Yeah. All right, and he is 1-to-1. Oh, I think cube is a he. Give him some pronouns here. Next is square root. It is 1-to-1. And then the last is absolute value. It is not 1-to-1. Because of the horizontal line test. Not 1-to-1, but we can restrict it just as we did the quadratic. Restrict the domain from 0 to infinity. Then it is 1-to-1. Okay. All right, number 5. I need a break for a second. The next one is finding and evaluating inverse functions, interpreting the inverse of a tabular function. It says a function f of t is given in the table showing distance in miles. Here's your distance in miles that a car has traveled in t minutes. Find and interpret the inverse of f 70. So I do this, and if you find a different way that you like to do it, please share that with me. I'd be happy to hear that. You know how we say that the domain of the function f is the range of the inverse and vice versa? So this would be the domain of the inverse, right? So if this is the domain of the inverse, it would be in the range of the f function. Okay. Because you can't, there's nothing on here that says anything about inverse. So we kind of have to puzzle our way out of this. I can say that because the domain is 70 in the inverse, that it's going to be in the range for the function f, which was who we're dealing with here. My question now is, what is t when f of t is 70? So I have to look where f of t is 70 right here. What is t? 90. So if f of 90 is 70, then the inverse of f of 70 is 90. All right. Go back and pause, go back and see what I did again if you were confused by that. What this means is because the 90s in minutes, it took 90 minutes to go 70 miles. Okay, that's what that means. Let me know if you have any questions about that. All right, evaluating the inverse of a function given the graph of the original function. All right. So we have find g of 3 and the inverse of g of 3. Okay, so let me see if I can clean this up a little bit. This is pretty blurry. Sorry about that. So g of 3, and what that means is when x is 3, what is g of x? Because we have g of x, which is our y. So when x is 3, find it on your graph. And then what is that on g of x? Because here's the g of x. Well, that's 1. So g of 3 is equal to 1. That's the first answer. Okay. The next one is the inverse of 3, of g of 3. sorry, the inverse, yeah, G of the inverse 3 is equal to what? Well, again, I'm going to do this one just like I did the last, not the last one here, but the last one before, where I said, oh my gosh, I said, well, if I know what the inverse of it is, and that's my domain of the inverse, it's got to be my range of my f. So over here, if this is in my domain for my inverse, that means I need to know, I know that it's going to be in my range for my G. So now I can ask myself, what is X when G of X is equal to 3? So now I have to come over here to my G of X and find 3, find it on my graph. Got it. And what is X at that point? It is at 5. So therefore G of 5 is 3. And if G of 5 is 3, that means the inverse of 3 on G is 5, which is what we wanted to know. Okay. Those little inverses are being stinkers, aren't they? All right, so the next one, it's very limiting, but just to show you in the whole real world thing, find a formula for the inverse function that gives Fahrenheit temperature as a function of Celsius temperature. Therefore, if they want you to put everything in Celsius, that means they want you to solve for F, because they want your function to have like a function of C. We're not going to do an inverse here per se, as far as writing the little inverse -1 up there. We're just going to solve for F, because if we solve for F, F will be by itself and everything on the right or the other side will be C, which is what we want. So right now we've got C is equal to 5/9 F minus 32. I gave myself a little space there because I'm going to do something here. I could go through and multiply everything by 9 and then divide everything by 5. But I also see that since we're in college algebra, we can just go like this and multiply both sides by 9/5. And I think y'all can handle that. These two reduce, we're left with F minus 32. Solving for F, I'm going to add 32 to both sides. And we get that F is equal to, I'm just moving things over, don't freak out on me. I've got F, I'm just putting it over here. I like my individual one to be by itself on the left. 9/5 C plus 32 is what it is. So 9/5 C plus 32 is going to be the inverse of the original function. Okay, and that's how you figure that. All right. Solving to find an inverse function. All right, well, these are going to be a little bit different. Well, actually, they're very similar to what we just did, but we just solved for F. In this case, we've already seen that the domain of F is equal to the range of the inverse of F. And we've already seen that the range of F is equal to the domain of the inverse of F. So if we're solving for an inverse, and we've got F already, and we need to find the inverse, that means that whatever we have over here is our range. So let me show you something kind of cool. Do you remember, and I'm not going to do this one yet, I'm going to do a little side notes here. Do you remember I've told you that F of X is equal to Y? I'm going to give you a little trick for these. So if you remember that, that's great, because I can take, I'm going to say I have a function. I'm using a different function. I'm not using this because this one has fractions. Let's ignore it. I'm going to give you a new F of X just to teach you how to do this. And then we're going to do it with the fractions. All right, so I need you to get this down. If I say F of X is Y, okay, once you switch it like that, now what we're going to do is we're going to switch places with our X's and Y's. Even if you have more than one X, you're going to put a Y in its place. If you have more than one Y, you're still going to put an X in its place. Everywhere you see a Y, you're going to place an X, and everywhere you see an X, you're going to place a Y. The next thing you're going to do is you're going to go back and you're going to solve for Y. Why did I switch it? So to solve for y, all I need to do is subtract 3 from both sides. I'm just going to move these around to make it look like I want it to look. There we go. I just switched sides. So I have just found the inverse of f. F is this. The inverse of f is x minus 3. What you have to do first, replace the f of x with a y. You can do that even if it's not an f of x, if it's an h of x, I don't care. Replace it with the y. And then for every x, replace it with a y, and with every y, replace it with an x. You're just trading places, okay? Now solve for y. Subtract 3 from both sides. We have y equals x minus 3. This is just making it to where I can write it proper. And then we have the inverse is x minus 3. Let's go back and do the one that I actually provided you. F of x is 2 divided by x minus 3 plus 4. To find the inverse, I'm going to replace f of x with y. Now I'm going to switch places. X is now becoming y, or y is becoming x. X is becoming y. And now I'm going to solve for y. So up here I switch x and y. And up here I substitute f of x, substitute y for f of x. So substitute y for f of x, switch x's and y's, and then solve for y, and then replace, after you're done with that, y, once y is by itself, y with the inverse of x. Okay, solving for y, I'm going to subtract 4 from both sides. X minus 4 is equal to 2 divided by y minus 3. I need y to move up top, so therefore I'm going to multiply both sides by y minus 3. All right, I'm going to clean this up real quick. I've got y minus 3 times x minus 4 is equal to 2, just to see what I'm looking at here. Let's get rid of the x minus 4. Divide both sides by x minus 4. Gone. Y minus 3 is equal to 2 divided by x minus 4. Last piece of this, I just need to add 3 to both sides. So y equals 2 divided by x minus 4 plus 3. And then finally, down here, I'm going to replace my y with the inverse of f. That is my answer. Alrighty. Let me know what questions you had. That's actually from an exam. I did that on an exam too. Find the inverse of the function. We're going to do the same thing. So f of x, start off with the function 2 plus square root of x minus 4. Now I'm going to replace the f of x with y. 2 plus the square root of x minus 4. I'm now going to switch the x's and y's. Y becomes x, becomes y. Now we're going to solve for y. We're going to subtract 2 from both sides. X minus 2 is equal to the square root of y minus 4. Still isolating y. Got to get rid of that square root. Square both sides. We get x minus 2 times x minus 2 is equal to y minus 4. We need to multiply these out. So x squared minus 2x minus 2x plus 4. It's just using the FOIL. And clean this up. And then remove this 4. So x squared minus 4x plus 8. We need to replace this y with the inverse. I'm going to move the y over here first, so it doesn't make me crazy. And so that's the inverse of x, of f, is x squared minus 4x plus 8. All right. So I'll switch my papers over. Any questions? Let me know. Oh gosh, I am all these. Oh, down to the last one. Cool beans. All right. Oh, this is our last lecture before the exam. So we'll have a review and then the exam. So good luck. Make sure you're comfortable with all of chapter 3, except for 3.6. All right, we're going to find the inverse of a function using a reflection about the identity line. Identity line is just on your, it's one of your toolkit functions. Given the graph f of x that's provided here, sketch the graph of the inverse of f. All right, so what I do here is I go through here and pick out just some numbers that I can see. First of all, I want to let you know that the identity line is this guy right here. It's just y equal x. And that's what the reflection is going to be across. Without even trying, that's what we're going to do. So I'm going to pick out just some points that are solid on here for me. So I can see that this is a 0, -3. And this one looks pretty solid. 1, 0. This one looks pretty solid. 2, 1. All right. So this is my f function. This is my f. So my domain for my f, just by looking at these three, and it consists of 0, 1, and 2. So my inverse is going to be flipping from 0 to -3 to -3, 0. From 1, 0 to 0, 1, and then from 2, 1 to 1, 2. I can now take those points, plot them, and get the inverse. So -3, 0. It's right here. 0, 1. And 1, 2. Okay, let's see if I can do this. I have to flip it around to make it a little bit easier for me. And it keeps going like that. That's pretty close. All right, so there is my sketch of my inverse graph. Okay, that's it. Let me know if y'all have any questions, and I will see you in class. Have a great day.